Hey everyone, today we are going to talk about solving log equations. So we're moving on into the next unit. So we're almost wrapping up the semester here. And this is actually pretty cool stuff. It might seem a little weird at first, and I think I probably say that about most things. But I promise you once you do a few, it'll be pretty straightforward and pretty easy. Okay, so solving log equations. Here's the idea behind log equations, and it kind of mixes in with exponential equations as well. They just call them all log equations. Here's the deal: if I have log base 2 of x is equal to log base 2 of 7. Well, I should be able to look at that and say, well, because these two things are equal to each other and these bases are equal, that must mean that these two things are equal to each other. And so we would then say, well, that must mean that x equals 7. That's the idea behind log equations. As long as everything is equal on both sides, then these two things have to be equal. They can't not be equal. Okay, so that's basically the strategy that we're going to use when we're doing all of these problems. There's lots of different problems that we're going to be looking at, different ways the problems can be presented to you. I'm going to go through some examples so you can see all those different problems. We're going to use the properties that we talked about the other day, lots of different strategies to solving all of these different types of equations. So hang on, make sure you have some paper and pencil and your calculator. You're going to need to take some notes on this, so if you need to pause the video, go ahead and pause the video and get yourself ready to go. Alright, so let's talk about a couple of different things we could have. First of all, we could have an equation where we are dealing with exponents. So let's say, for example, I have 3 to the x plus 1 is equal to 3 to the 4th. Now, there's a longer way to do this and a shorter way to do this. I think in your book it gives you sort of the longer way, a couple of extra steps in there that you don't really have to do, because this is very similar to this problem up here. We have common bases already. We have this equal sign. That must mean that this exponent and this exponent have to be equal to each other. And so x plus 1 has to equal 4. And then that's very easy to solve. I subtract 1 for both sides, and I get x equals 3. So seemingly problems that might look really hard to solve are actually going to be pretty simple once you get it into the basic form. Now, you might be given problems, and I shouldn't even say might, you will be given problems where those bases aren't going to be the same. And in that case, what do? Well, there's two different situations you can have. You can have a situation where the bases can be manipulated to be the same, or there's no way to ever get them to be the same. So let me show you those two different scenarios. Let's say we have a problem like this. So 2 to the x is equal to 4 to the x plus 1. Now, clearly those bases aren't the same. However, I can write them so that they are the same. Now, keep in mind, I am not changing the value of anything. This is an equal sign. So I can't change it so that they're no longer equal to each other. I can change the way I've represented a number. Right? I can say that 4 is equal to 2 squared. I haven't changed equality, I just changed the way I wrote it. And if you look over here, I already have 2 as my base. So if I rewrite this side of my equation so that it has the same base as this side, well, that's going to make my life a lot easier. So I can rewrite 4 as 2 squared, and then I have this x plus 1. Again, I haven't changed anything, I just rewrote it a different way. I haven't changed the value of anything. I just changed the way I represented a number that I already had. Now, when you raise an exponent to a power, this is stuff that you've done before, you need to multiply those together. Okay, so you end up with 2 to the x is equal to 2 to the 2x plus 2 when you distribute that 2 to the x and to the 1. Now I have a situation where my bases are the same, I have this equal sign. That must mean that my exponents have to be equal to each other. So I have x is equal to 2x plus 2. And now I can easily solve for x, right? If I subtract x from both sides, and then I subtract 2 from both sides, I end up with negative 2 is equal to x. Okay? Again, notice all I did was change the way that I wrote 4, and I wrote it as 2 squared. Now, some people think, and they make this mistake more often than not, but they say, oh, well, 2 is the same as 2 squared, and they just rewrite this side so that it's 4, right? So that they have a base of 4. You can't do that because then you're changing the value. So you always want to look at the smaller number and get the larger number written in the same format as the smaller one. That way you're not changing the value of anything. Okay, so we have situations where our bases are already the same. You just set the exponent equal to each other. We have a situation where our bases are not the same, but we can make them the same by just manipulating one of those numbers. Or we have a situation where our bases aren't the same and there's no way to get them to be the same. And let me show you what that looks like. If you have a problem like this, 4 to the x is equal to 11, right? There's no way I can convert 11 into some form of 4, right? There's nothing I can do with that. So in this situation, all you're going to do is take the log of both sides. Okay, literally that's all I'm going to do. Ready? Here's what I'm doing. I'm saying the log of 4 to the x is equal to the log of 11. All I'm doing. Okay, I didn't do anything fancy. I just took the log of both sides. It's the same idea as if you divided both sides by 2, or if you added 1 to both sides, or if you squared both sides, right? As long as I do the same to one side as I do to the other, I can do that. And so now I can use one of my properties, right? I have this property that allows me to bring that x out in front. It was the third property that we learned. So I can rewrite this side of my equation as x times the log of 4 is equal to the log of 11. Now, I have actually a very easy problem to solve from this point, because this is all I have to do. Watch this, this is cool. All I have to do is divide both sides by the log of 4, and I've got an x by itself. And to do log of 11 divided by the log of 4, I can just do that in my calculator. So I've got log 11. Make sure that you close your parentheses. If you don't close your parentheses, you're going to get a different answer. Log of 4. Oops. I think I have one too many parentheses there. Log of 4. And you get an approximation 1.7, I think it rounded 1.73 approximately. Okay, so those are the 3 different types of those equations. You could have a problem where your bases are the same, but your bases are the same, so you set your exponents equal to each other. You can have a problem where your bases aren't the same, but you can get them to be the same by changing the larger one and writing it so it's in terms of the smaller one. Or you can have a situation where the bases aren't anywhere, there's no way to get them to be the same, and in that case you would just take the log of both sides. Okay, so those are three different scenarios when you're talking about, I like to refer to them as exponential equations because your variable is in your exponent. We also have problems where we are given log equations. So let's say, for example, I have the log, right, log base 2 of 7x plus 1 is equal to log base 2 of 2 minus x. Again, I have a common base here. Everything here is the same. Log of 2, log of 2. I have this equal sign, which means this side of my equation has to equal this side of my equation. And so I know then that 7x plus 1 has to equal 2 minus x. Just by laws of equality, that has to be true. Well, then it's just a situation of solving it, right? If I add x to both sides, I end up with 8x plus 1 is equal to 2. 8x, subtract 1 from each side equals 1, so x is equal to 1/8. Okay, so that's pretty straightforward when you have a situation where those logs are equal to each other. Okay, if you have a log equation that seems to be written a little bit differently. So let's say, for example, you have a log equation where you only have one log. So you have log base 6 of 2x plus 3 is equal to 3. Okay? These two sides are not equal to each other. I don't have a log on both sides. It doesn't look anything like this problem. But here's the deal. Remember that the first time we learned about logs, we said, oh, I can convert from log form to exponential form. I can switch back and forth. Well, we can do that same exact thing here. As long as I have this in log form, I can convert it to exponential form. Right? I can say, well, okay, let me change this. Here's my base. Here's my exponent. So I can say, well, 6 to the third is going to equal 2x plus 3. And now I have a very straightforward problem that I can solve. 6 cubed is 216. You can do that in your calculator. 2x plus 3. Subtract 3 from both sides. You end up with 213 is equal to 2x. And you end up with x is equal to 213 over 2. You can leave it like that, or you can do it out in your calculator. Either way is fine. But that's all you're doing. So these are two different types of log equations that you might have. If you have the logs on both sides of the equal sign and they equal each other, then just set those two things equal to each other and solve it. If you only have one log on one side of the equation, change it to exponential form and solve it. Okay, so there's lots of different examples here. I'm going to actually make another video to show you how we incorporate the laws and things into this. But that's the idea behind this stuff, okay? It's just a matter of understanding what equality is and that you can set things equal, or sometimes you just have to do a little bit of manipulation sometimes to get to where you need so that you can solve it. These are some examples. Like I said, I'm going to have another video showing you how to solve some problems when we have to use the properties. Okay, that's it for now, folks. I'll see you later. Take care. Bye-bye.